This is difference of squares. So if you'll remember back to special products, remember we did products like this when you had to multiply binomials. So I took x times x and I got x squared. And I took x times 2 and I got 2x. And I took negative 2 times x and I got negative 2x. And then negative 2 times 2 and I got negative 4. And then when I was simplifying this, these like terms canceled out. They added to 0, so I was left with x squared minus 4. So that was a special product we have. Now what we're going to do is we're going to factor. So we're going to get this, and you need to factor it to this. So some things you need to make sure you recognize here is we're talking difference of squares. So first thing, difference means there must be subtraction or plus a negative. Also, both numbers need to be perfect squares. Something has to multiply by itself to equal 2 and to equal x squared and to equal 4. If I had x squared minus 3, this would not work. 3 is not a perfect square, so it has to have a difference and a perfect square. Let's look at number 1. So, I have a difference. These are perfect squares, so I can write my factored form. 4h minus 3a, 4h plus 3a. And I'm done. I've taken the square root of each. I have, remember it's a product of a sum and a difference. Here's a sum, here's a difference. And it gives me that. Because I have the exact same terms, only have a minus and a plus, the middle terms will cancel out. Just like we looked at, the middle terms will cancel out. So we have something that's minus something and plus something. So we're done. Now again, always check if you have a greatest common factor first, and see if you can apply the technique more than once, because often you can. Let's look at number 2. I have starred this because I can factor out a greatest common factor first. My greatest common factor is 3 and g, because both of them have a g. So 3g, so 9g squared minus 1. This is a difference of squares. Again, this is a perfect square because 1 times 1 is 1. This is a perfect square and it's a difference. So 3g minus 1, 3g plus 1. And now I'm done because 3 is not a perfect square. I cannot factor it anymore. Let's look at number 3. Again, is this a difference of squares? Yes, it's a difference. Yes, these are perfect squares. So, b squared minus 4, b squared plus 4. Now this is where you have to watch. I'm not done. I still have a difference of squares. Not here, because this is a plus. That's a sum. Here's a difference. That's a perfect square, and that's a perfect square. So b minus 2, b plus 2. So this one can be factored down into 2. This one has to stay because it's not a difference. It's a sum. Now when you're looking at variables and you want to know, is this a perfect square? Your answer is, if it's an even number, like 4, then yes, it is a perfect square. If it's an odd number, then no. Here, I have b to the first power, so it's not a perfect square, and neither is 2. Here, b is to the second power, so yes, that is a perfect square. Yes, 4 is a perfect square, but this is a sum. It's not a difference. It has to be subtraction. Let's look at number 4. Do I have a difference? Yes. Do I have a perfect square? Yes, my exponent is divisible by 2. It's an even number. And 1 is a perfect square. So, y squared minus 1. Y squared, 1. double check. Do I have any more? Can I do it again? Not with this parentheses because it's plus. So I definitely can't do it here. But is this still divisible by 2? Is it still an even number? Yes. So I can do y minus 1, y plus 1. And that part still stays. So I broke that down to 2. So you know if you can factor if these are both perfect squares and it's a difference. It has to be a difference. Number 5. Again, I wrote this star here to show you that there's a greatest common factor. 5 divides into both of these, and also x. Both of them have an x. So I have to factor the 5x. What's left is x to the 4th minus 9, because I took a 5 out of there, and I took an x. Now, can I factor these as difference of squares? Yes, this is an even number, and this is a perfect square. X squared minus 3, x squared plus 3. So I need to check, can I do it again? This is an even number, this is a difference, but 3 is not a perfect square, so I'm done. Okay, and the last one kind of goes back to grouping. It's a little more complicated, so that's why I want to show you an example here. I have 4 terms, so I'm going to factor by grouping. So I'm going to factor these two. I'm going to find the greatest common factor. It's 7x squared, x plus 3. Okay, then over here, my greatest common factor is 7. Okay, so I have this. Going to write my answer, x squared minus 7, x plus 3. So hopefully that's review. But I'm looking at this, and I haven't completely factored it because in here, both of these numbers can be divided by 7. So I need to change that to 7, x squared minus 1, x plus 3. So I took this set of parentheses and I moved a 7 out. Now when I look at this, it is a difference of squares. These are perfect squares and it's a difference. So 7, x minus 1, x plus 1, x plus 3. Again, that's a complicated example and one of the more difficult ones, but you can do it. Just make sure you check if it's a difference of squares, double check your answers. So I get here, I think, whoa, I'm not done because both of these are divisible by 7.